So I'm very happy to be giving this course with my two dear colleagues, Dorothée and Tuhami, who are great experts of CGE modeling in the region and who have also published widely on CGE modeling. So the structure of those 4 days is as follows. In general, we have 4 sessions, as you know. Each session is divided in 2 parts. So we have a session of 1 hour and a half, then we break for 15 minutes, and then we continue with 1 hour and 15 minutes for the 4 days. So today, tomorrow, and then next week also on the same days with the same setup. Before we start, we will be mainly covering different topics in CGE modeling. So today we will have an introduction to macro and micro tools that are needed to build CGE models. So this will be mainly given by Tuhami and Dorothée. And then tomorrow, Dorothée will present the first model that we will be working on. I will be giving the second model, which builds on the previous model. And then next week, we cover 2 different topics. The first one is on dynamic modeling in CGE models and how to replicate those macro shocks from the macro level at the micro level through what we call the microsimulation. And this will be so the dynamic part will be taught by myself, and the microsimulation part will be taught by Tuhami. So that's the overview of the 4 days. I think I will stop here, and then I will leave you between the safe hands of Tuhami. Thank you so much, and over to you, Tuhami.
Thank you, Shahir. Hi, everybody. I am Tuhami Abdel Khalq. I have to present with my colleague Dorothée the session of today. Dorothée is on the computer. She has to share the presentation. Can you see the presentation?
Yes, we can.
For the first part, we are presenting the introduction of CGE modeling for those of you they have not know what is a CGE modeling, and after that, in the second part of the session, we will present a micro and macro foundation of a CGE modeling. We have to look on some specifications. Just to be clear, my English is not perfect, but the slides are in English. I can explain in English, in French, and in Arabic if you need. For the introduction for these topics, we have to present the overview of the CGE model and the field of application where we have to use the CGE modeling, and we will see the steps to construct a CGE modeling and some limitation of that CGE model. If you have any question, we can just stop me and if you to raise your hand and you will see.
Full screen.
No problem. So, in many countries, the modeling is modeling in general has been introduced in developing countries, like our countries, by the international institution, mainly the World Bank and the International Monetary Fund. And from that, these tools coming step by step are very important tools for economic policy analysis. And today, we have many CGE modeling constructed in our countries. As you said before, many of you are working in a CGE department or finance, Ministry of Finance, planning institution. So
Continue.
Okay, the CGE modeling is now a very important tool in policy analysis. So when we are looking on that, there is several factors that help in this direction. The first one is a growing awareness by the policymaker of the usefulness on the relevance of these analytical tools. CGE modeling is now known by the decision maker. And there is a growing availability of humans in our countries to construct and at least to understand and to manage this model to participate to the construction and to manage this model. And there is now advanced computer science. We have now in a small computer, we can construct a big CGE model. We have a softwares, mainly GANs, and we have in this training an introduction to this software. And we have programs, we can exchange programs with colleagues to solve this model numerically. And there is a growing availability of statistical information to construct the data set we need to run this CGE modeling and to construct social accounting matrix. So these factors help us to construct CGE modeling to test and to simulate any policy where we can use these tools. And now, as I said before, there is a department in our countries where we have a CGE modeling, Department of Finance, Planning, and other. And this model, important feature of this model, they are different from those generally used in developed countries. Because in developed countries, we are using a macroeconomics model generally, and in developed countries, we are using a CGE modeling. Why? What is the difference between the two? In the developed countries, the content is in a demand part, but in developing country, we have a content of supply. So, and there is a difference. The CGE model are generally disaggregated, and macroeconomics are aggregated. So there is two types of model when we are in tools in economic analysis. There is econometric modeling and there is a CGE modeling. The macroeconomic modeling are more used in developed countries, and the CGE model are used in the developing country. To use these tools, because the CGE modeling is a tools, and it is used to evaluate and to quantify impact and to simulate impact of various economic policies. Generally, we can use a CGE model in ex-ante analysis, not ex-post analysis. They are this model, a CGE model, are flexible, generally flexible because we can aggregate agent, activities, products as the problematic needs, but we have a rigorous framework. Generally, the CGE modeling are current, and we can answer several economic issues. For question can be complex. This is another very interesting feature of the CGE modeling. So for this characteristic, there is a great interest of this model for researchers, students doing a master research or a PhD, and modeler working in the ministry department or international organization, etc. And this model, the construction of CGE model started in last century and used in developed country, met more and more in development country. They are, as I told you, it's a general disaggregated, coherent, and complex framework. And CGE modeling can give us answer more than what we can yield by a partial equilibrium analysis. So the CGE modeling is very interesting tools. When we are using a CGE model, we can give answers on a microeconomic level, because as Shahir told you before, we can use a microsimulation and we can see the impact of macroeconomic policy on households, on firms. So we can get some results in a microeconomic level. Obviously, we have a result in a sectoral level, depend on the disaggregation we have, and we can ask also for a macroeconomic situation. So this impact, it's very interesting, but we have to be aware that when we have to construct a CGE model, we must have the question before. We cannot ask questions after the construction of the model. We have to know what is the problematic we have to construct, to address, and with that, we can construct the pertinent CGE, the pertinent model, if we have to look for a microeconomic answers, sectoral answers, or macroeconomic situation. And with the CGE model, we can see exactly what we have and the shock we have. In French, I don't know in English what we can tell that. Rien ne se perd, rien ne se gagne dans un modèle d'équilibre général. We can to look exactly where it all flows in what we are doing. For example, if there is a user on a subsidy of sector energy, or I don't know, improve the production, increase the production in energy sector, or decrease the supply on the energy sector, we have many effects in the sector, in the energy sector, but also beyond that for all other sectors. We can have the impact of the effect of the shock, the policy. The shock can be extra economic one, and it can be also a policy. So we can look what is the consequence of this policy on intermediate consumption. This is a feature that we cannot have in a macroeconomic model. And we can have an income variation for each agent. More than that, we can have the impact of each household in assury. We can see what is the impact on collected taxes for the government, and we can see what is the variation in demand side, in supply side, in price, in import, in export, in external balance, in employment, etc. So the CGE model can answer many questions at different levels and in different variables. At the theoretical level, CGE models are based on a Walrasian general equilibrium theory. I think all of you had courses on microeconomic courses, and what is the general equilibrium and Walrasian general equilibrium. So when we construct a model, a CGE model, we have some features coming from the microeconomic level. And we can look off the Walras law and numeraire and relative price. This is coming from the general equilibrium. In the name, we have CGE, it's a general equilibrium, and it's a computable. What we have in a CGE model, we have a theoretic general equilibrium from the Walrasian theory, but we can give and extend it to a computable general equilibrium. And in this model, we have to modelize, we got to construct several behavior, and we have to manage variables, many endogenous variables. So by construction, this model leaves a plus for redistribution effect between agents, because particularly between households, also between activities, can also be to approximate the effect on a specific sector or subpopulation. If we have to modelize urban households, rural households, or also other stratification of the population, the CGE model can answer for any question in this situation. So I think CGE model is very useful in modeling and to look what expected impact for a policy on poverty situation if we are using a micro simulation at what we have to see in the last session of this training. the features on the CGE model also is we can determine quantity on each market and equilibrium prices. All this can be simultaneously determined because we are in a general equilibrium framework. So when we do a simulation with a CGE model, this provides us with a midterm or long-term effect. Generally, CGE model cannot be used, it's not useful to use it for a conjunctural, to see conjunctural shocks. If you have a question, we have to answer for short-term situation, or CGE model cannot do forecasting. We see why, because generally with a CGE model, we can do simulation. There is a difference between simulation and forecasting. Even the CGE can be dynamic, generally we are using the CGE model if it's dynamic to do simulation. It's the same thing if we are static. But I have to emphasize here that we cannot do it. CGE model is not good tools to do forecasting. Now, we have to answer some question for doing that. Why we have to use a model? Why we have to use a CGE model? Particularly when we have to use a CGE model, and when we cannot use a CGE model. This is a real problem, because some researchers, some students want to use a CGE model when we cannot use a CGE model. And for that, what is the alternative model we can use to address some questions? We have to present also a main practical steps in building a CGE model, and we discuss there is many limits of these tools, as all other tools. CGE model has many limits. We have to discuss two types of limits: theoretical limits and practical limits. In the internet, you can find obviously many references. If you type in your computer now CGE model, you found many paper and many literature review on this. We select some of this. There is also many groups of modeling around the world. The one is the ERF, where you are today, but there is also GTAP, I think in Purdue University. PEP is also from Laval University, and now in Kenya, I think. There is ECOMOD, and there is many other networks where there is a training on a CGE model. This is what we are presenting today with Shahir and Dorothy. It's an introduction to that, but there is many other sites where you can look for many other resources. For application now, we can use, as you see, you can use a CGE model when we have to deal with a multi-sectorial policy, where the simulation or the policy we have to analyze is in a can have multi-sectorial impact. It can be in agriculture policy, in energy issues, in regional integration, in international trade. Many of you are working on international trade to analyze what is the impact of trade liberalization on sectors, on poverty, on sectoral analysis. So in this situation, we can use a CGE model. Generally, CGE model is used when we have when we have to disaggregate the economy. What it means, disaggregate? Some of you are looking for the input-output analysis, Leontief analysis. The CGE model is a generalization of a CGE on input-output analysis, in the sense that the input-output analysis, in the input-output analysis, in the Leontief analysis, price are exogenous, and the equilibrium is reached without the price, no role of the price in our input-output analysis, and the price are exogenous. In the CGE model, the price become endogenous. So the l'ancêtre, the grandparent of CGE model is input-output analysis. So for that, CGE model or modeling is a disaggregation of the economy. We have several branches, several activities, several products. And we have to identify somewhere the impact of any policy on sector, because generally we have some sector benefiting from the shock, and those, or there is some other activities will be reduced. And with CGE model, we can know what is the consequence of a shock or a policy on the economy, in the macroeconomic level, on the sectorial level, and perhaps in the microeconomic level. So this is the powerful of the CGE model. Of course, the CGE model, building a CGE model is a complex operation. Many students come to ask me, can I construct a CGE model for my master thesis in 4 months? No, generally no. We can't, if we want to construct a CGE model, generally we have to do it with the multidisciplinarity teams in a department. You can deal with a model coming from someone, and we can transform it to change some features or some blocks from a CGE model. Yes, we can do that in 4 or 3 or 4 months, but we cannot construct a real CGE model for a country in a short time. We need more time, and it can be time consuming, and we need generally, if we are in a department, a multidisciplinarity. For a pedagogical only purpose, we have here many steps, the important steps to follow. You can stop me if there is any question. My colleague Dorothy is here. If you have any question for the steps we have, you can raise your hand and we can take your questions. Si vous avez des questions, allez-y. إذا كانت هناك أي سؤال أنا موجود للإجابة على التساؤلات. أنا أنظر في نفس الوقت للوقت، ولكن إذا كانت هناك أي تساؤلات تمام. If you have any question, I am here for that. So, the first thing we have to do when we want or we can use or not use a CGE model is to ask, what is the problem? That when we have to use a CGE model, we have not to go through a computer or to a software or to equations. No, the first step to have to do, this is my experience, I tell you that this is what we have. We have to ask, what is the problem posed with the policy we want to stimulate? From that, we can provide a coherent answer for the specific questions. We cannot construct a model for many problems. We have to construct a model focused on the question we have. We can transform some inside the CGE model, but when we construct a model, it's oriented to answer a question. In any country, we have many models. We can have in the same countries 10 models. One in Ministry of Finance to look for fiscal policy, the other one in the central bank to look for, I don't know which the problematic, another one in the Ministry of Plan, another one in Agriculture Department, because each department has its questions, and we have to construct a model to answer some specific questions. We have to prioritize questions because sometimes we have a list of questions from the same decision maker asked us for many questions in there. We have to prioritize to look what type of CGE model we have to construct. And the second question we have to ask, this question, at least the important question, can be addressed with a CGE or not? If so, we continue. If not, we stop. And we have to look for another tools, another analytic tools in economics. But how can we answer that we can or we have to use a CGE model? To use a CGE model, we have to look for three conditions, and they must be, the three conditions must be simultaneously satisfied if we have to use or not a CGE model. If it's satisfied, we can continue. The first one, the policy we have to simulate must be evolved for several sectors. This means that we have intersectorial relationship between sectors after this policy. If we have to look only on a macro level, we have not an intersectorial relationship, or the policy is not important for an intersectorial relationship, we have not to use a CGE model. This is the first one. The second one, the policy we have to simulate must modify relative price, because we have to look, I told you before, it's a Walrasian model. So when the relative price does not change, the equilibrium cannot change. This is what we learn, all of you, all of us, from the Walras model. So if we had the relative price to change, the price can be price of factors, salary of capital earning, or a price of good. If there is the rapport, the relative price change, we can use a CGE model. This is the second question here. The third one is that the simulation of we have to run with our model must have a macroeconomic effect, a significant macroeconomic effect. I will give you an example here. If we are in a country where I don't know, I give generally the example I had some years ago to look what is the impact of the reform of fishing in a fishing sector in some country. Yes, it's a good question, but it's a good question if that's the impact of the policy in the fishing sector impact macroeconomic. If the fishing sector is a small sector in our economy, if the impact is important for the sector, but we have not the macroeconomic effect, we cannot use a CGE model. We have to use a CGE model when the sector where the policy is implemented must have a macroeconomic effect. What is macroeconomic effect? The balance of trade, the public budget, the allocation of factor between sectors, etc. I can give you an example. I don't know what will be the impact of the sector of energy in Senegal and Mauritania, because we have a new allocation or endowment on gas and petrol. Yes, because it's a great shock, and we can have the impact, the macroeconomic impact. But if you have to analyze a sector where the impact is small, there is no macroeconomic effect, we can use it. To synthesize, when we have to use or not use a CGE model, when we are looking for, there is a multi-sectorial analysis, when the relative price is modified, and there is a macroeconomic effect. If these three questions are not simultaneously satisfied, we have not to use a CGE model. So we continue now. What is the economic and social and institutional context of the issue? The third question we have to ask is what is the level of the disaggregation we can have? Have I to answer to the social impact? If yes, household level, we must have household be poor, rich, middle class, others, or we have rural, urban, or we have other stratification. In the institutional context, if we have to look for, I don't know, in some countries we have a federal level and a regional level. Question on the three conditions that needs to be satisfied to use it. Can you give us an example of what? Which one? Which for which situation? I come back there. I don't know from the question. Yes, I can give you example to see what we want to use in some situation. Suppose in a country we have to subsidies for some energy. We can take the Moroccan case or the Egyptian case, and the government is looking to cut the subsidy for many goods. Okay. And we have together to look what is the consequence of this policy from the government to cut the subsidy. So it's clear to cut the subsidy of energy or for other goods, it has many impact on a sectorial, there is an intersectorial ratio. And the price, because some sectors or some goods are more subsidized than others. So the relative price are impacted. The relative price change. And we know if we cut the subsidy, we will import more or less. There is an impact on trade balance. There is impacting the budget, public budget, because this is exactly why the government wants to do that. So the conclusion, yes, if we have to analyze what is the impact of cut subsidies, it's interesting policy, and we can use a CGE model. I can give you another example where we cannot use directly a CGE model. If you have to put in place, I don't know, a policy in a health sector, to change something in a health sector, I don't know, residualization or something like that. It's not clear that we have to use a CGE model in this situation, because it's the impact there is no a macroeconomic, at least in the short term, there is no macroeconomic effect of this policy. So it depends on the question you have. So if you have a specific question, we can see and to look if we have this. So I ask you now, for each of you can look what is the question you have, and to look if these three conditions are simultaneously satisfied, and to go for the next. Okay. After that, we look for the. We look at the institutional context, what agents we have to take in consideration, which activities we have to take in consideration, what is the disaggregation we have to use. So the construction of a CGE model is not a technical operation in the beginning. It can be to look for a legal context, and we have to look for a legal report. For by experience, we had to construct a CGE model, and we will go to look exactly the definition of the policy from texte de loi, I don't know, from the legal context. This is another question. After that, can this question addressed by the CGE model? The answer is yes. Sorry. Okay. And when we are answering this question, we know now the model, the structure of the model, the agent we have, the branch, the level of disaggregation, and all of this give us the size of the model. It's a very, very important question here. And please, listen. When we have the data of disaggregation, as a researcher, we have the problem. We want to disaggregate all things because the conjecture is when disaggregated is more interesting. Yeah, perhaps yes. But generally, there is many difficulties coming from that. If the model is disaggregated, we need more data to solve it. The finesse of the analysis of economic, social, and social context is important. And there is a trade-off between the temptation to have a very detailed model, it's important, but the ability to fit with a statistical data. And sometimes we have to come back because we cannot solve the model because we have not data to do this. I give you an example. Look, if you have many sectors and we are looking for the impact of a policy on the labor market, there is our colleague, I think Ali Suwad, we are looking for the employment after this policy. That's good. But we can add another question. What is the impact of this policy on a gender dimension in male and female in a CGI model? We have many sectors. Yes, it's a good question. But we have no data. We have no salary from each sectors by gender. The question is good, but we have no data. We cannot feed the model with the statistical data. This is a limitation, and we cannot construct the model with that. If we take many factors simultaneously in the model, because it is too disaggregated, this will introduce many difficulties, and it will be difficult to interpret. Sometimes more aggregated model, it can be aggregated, it can be more focused, and it can be more relevant. So we have to see there is a trade-off between a disaggregation and a data we can use to calibrate the model. Yes, to calibrate the model, this is the word. How to calibrate a model? This is perhaps a word some of you are using, but I don't know what is the interpretation you give for this model, because we can use to calibrate a model in a growth model. We can calibrate a model in the SGE model or in a real business cycle model. The calibration in the CGE model is different. What is the framework you are using in a CGE model? We construct accounting, what we call accounting, social accounting matrix. Social accounting matrix. We'll discuss that if we have time. What is that? It's a framework, it's a table where we put all the flow in economics between agents, activities, and products, and rest of the world, import, export. And we have, when we construct that, after the construction of the sum of the social accounting matrix, we have to specify, this is a microeconomic approach, the agent and branch behavior. The next part of this session, we will come back to how to specify the behaviors. We have to be an economist. We have to be a microeconomist generally. So we are constructing a CGE model. We have to look for a legal problem, institutional analysis, accounting framework for SAM, and microeconomic. And after that, we can construct, we can write all the equation of the model. In a mathematical word, a CGE model is a succession, is equations with variables, with parameters. So a CGE model is a big model, is many equations. We'll see some of this model for the tomorrow and the next week. And we have the general structure of the model must be answered at least two queries. a CGE model, when we construct a CGE model, we must have in mind two characteristics to satisfy. The first one is the economic one. If we construct a model, it not satisfy the axiomatic, economic axiomatic, the model cannot be interesting. It will be wrong. We cannot use it because it is not the coherence, economic coherence is not here. The second one is the mathematical coherence. In a CGE, the CGE model must be coherent in a mathematical world. So we have two characteristics when we construct a CGE model. The first one is economic coherences. The second one is a mathematical coherences. We're aware that we have to look all of these things. When we construct this model and we have all the equations, as I told you, generally we have some parameter in the model. We have equations, we have variables, but also we have parameters that we don't know what is the parameters. We have to, not to estimate, but to calibrate. Yes, there is a question. Is the accounting framework based on national accounting? Yes, good question. Yes, it is based in a national accounting. This is the first one, but also generally the Department of Plan or of Statistics in countries construct a sum or at least an input-output table, generally. Yeah? But it is not, generally, it is not sufficient to construct a sum. You have to add many other data from other sources, from household survey, from industrial survey, for economic census, etc. So yes, we need to use accounting data from national accounting, comptabilité nationale, المحاسبة القومية, but also we have to use data from other documents, from other sources. In some situation, we have to use data from surveys, from household, or from agriculture department, or from, I don't know, is the commerce exterior trade, foreign trade, or from douane, etc. We have to use many data in the same framework. This is the answer for this question. So, calibration. What is calibration? In the CGE model, we are doing the CGE modeling. The calibration is how to determine the numerical value of all parameters. In a CGE model, we have many parameters, and the calibration is the approach we have to use to determine the value of these parameters. Some of you coming from econometrics, like me, I am coming from econometrics, but when we are looking for the calibration is a particular manner to estimate the parameter of the model. We have not to use last square or GNM or order. Calibration is how to determine numerical value from only one observation is the sum and some free parameter. And the free parameters coming from literature or other estimation outside the model. So calibration, it's coming from the sum, and sum is only for 1 year, and from other value, other free parameter coming from that literature. So when we have to calibrate the parameter, there is a logical to do that. And the logical is too rigid. We have step by step. We cannot do nothing, something before the order one. When we are doing calibration, if we have, just to give you an example, we have 3 parameters to calibrate. Generally, it's a nested situation. We have to fix the first one or to estimate it outside the literature. So the second parameter must be linked the first one, the estimation of the first one. The third one must use the 3 other. We cannot start by the third one to give the value of the third one. So we have a logical procedure to calibrate this. So this is the calibration. If we have time, we can go to explain more and more. Now, with our model, we have a structured mathematical model, structure of the model. We have the value of our parameter. When we are coming to count the number of variables and the number of equations in our model, there is a gap between the two. Generally, we have more variable than the number of equations in our model. We have more variable than the equation. We cannot solve this model in a mathematical way. A model can be solved only if we have the same number of equations than of the variable. So we have to look what is the approach to fix some of these variables. This is what we call closures in this model. Closures is to make some variable exogenous. This is a closure. It's a critical situation because with the exogenous variable, this is the entry to simulate. When we have to do simulation in a CGE model, the simulation can only done through the exogenous variable or sometimes for some parameters in a sensitivity analysis. So the closure in a CGE model is the way we can use to fix some exogenous variable to have a square model, square model carry, where we have the number of equations equal a number of variables. After that, when we are sure that we can go ahead, we have to use a software because the model generally, we have 1,000 of equations, perhaps 100, perhaps 1,000, many equations, and we have to solve it. It's clear we have to use a software. And we have to know how to translate our model in the software we are using. Generally, in when we are using now, we can use a GAMS. GAMS is a general algebraic model system, and we have a presentation, I think, tomorrow, and introduction, a small introduction of this. Is a powerful software to solve linear and non-linear model. And in the software, we translate our model and to make calibration, to solve the model for the reference year, to reproduce the sum, and after that, we can do simulation. This is the steps. We take all what we done before to put it in a numerical form in our software. When we simulate, we have to write a report for the decision maker. We have to write a story. This is why we construct a model. We have to write a story to interpret that simulation. And only the team who built the model generally can interpret the result of the model because there is a disaggregation, there is a behavior, there is a data, there is a sum, there is a calibration, and the team has to interpret the results. In many situations, I had to look for a model that I don't not construct. I cannot explain it. I can, but it takes me times. But if I construct the model, when I simulate, I know what is the interpretation I have to present and how to write my report. When we are writing a report after a CGE model, when we write a report, we don't need to give to the decision maker equations. We cannot explain him the calibration. We cannot explain him the closure. We have to write a story. Well, this is the impact. This is a table of results. This is the policy consequences. So this is generally the steps we have when we are construct a model. I'm looking for the time. I know in yes, in 20 minutes. We can be in time. I hope. Do you have any question for this part? Because now I will go to a limitation of SCG model. Yes, we can take some question if you have. And I don't know how is my English is correct. This is the first time I give this in English. Okay.
I have a question, but yes. I don't know if it's too early to ask it, since maybe it will be we will have the answers in the upcoming sessions. But I will ask it, and we will see. When you are talking about the calibration, and then you said that we will need also data.
Yes.
But the calibration, as I see it, is we fix from the literature or something or another model the parameters of the model, and we simulate, if I'm not wrong. So what's the data, like when you said we construct the accounting framework, what are we doing with that?
Yes. When we calibrate a model, generally in a model we have 3 kinds of parameter, if you want, three types of parameter. We have some elasticities that we cannot calibrate from the sum. The accounting framework we have is the social accounting matrix. In some situation where if we are using a CES in the production side, or we are using a LES in the, we'll see some of this specification, or a CET for trade, there is a parameter we cannot take it from our accounting matrix, okay? We have to use some estimation or approximation outside the model. This is the free parameter. After that, we have to calculate from the sum, the order parameters. So we have 2 kinds of parameters, free parameters and calibrated parameters coming from the free parameters and the data from the social accounting matrix. I hope it's clear. I can send you any.
We will see some examples.
We will see some.
Yes, thank you very much.
But I hope it's clear. Yes, is there any other question? Okay, if there is no question now, we'll move to a limit, the limits of a CGE model. To be honest, when I am looking for the limit of some models, some of my students decide to no go in a CGE model because there is many limitations in a CGE model. It's a very interesting tools, but there is many limits in the CGE model. And we select, with Dorothy, we select only some of these limits and classify it in theoretical limits and practical limits. And we select. First one is from the question before, is exactly the CGE model are not estimated by econometric procedure. And to be honest, this is exactly the windows I am coming in the CGE model, because my thesis is done exactly in econometric analysis of a CGE model, a statistical inference of a CGE model. But this is a weakness. And as a researcher, we have to improve the CGE model by new approaches. So what you have to know that CGE model cannot be tested against time series data. Because there is no uncertainty in the definition of a CGE model. There is no stochastic part in a CGE model. It's not like a DSGE model or a VAR model or order. The CGE model are not estimated, they are calibrated from exactly what I told before, from a free parameter and a sum. Some free parameter is coming from outside. And sometimes it's the choice is arbitrary. And there is an uncertainty from this. So the CGE model, we can, in the calibration, orient the results. We have, in more advanced work, there is a possibility to construct confidence intervals for the result of a CGE model, but the limit is that the CGE model are not estimated like other model because we are not using a time series data and there is no stochastic component on the equation in a CGE model. It's unlike that of the SGE or other type of model. Next, second limit. The most common version of the CGE model are a statistic description of the economy. So when we simulate a policy, or we are looking the impact of a shock, extra shock on the economy, for which we construct the model, we are doing only a static comparison from the initial situation and the final situation. And we don't know how many time we will take before we're comparing the initial equilibrium and the final equilibrium, because the model is a static one. Of course, we can construct a dynamic model. I think that the first session of the next week, Shahir will have a presentation on how to construct a dynamic model, but it is more difficult and it's difficult to solve, but it's very interesting. And some situation we have to use a dynamic model. I discussed it with Dorothée before this session. If we have to look on the reform of pension system, le système de retraite. Si on veut voir quel est l'impact de la modification d'un système de retraite dans un pays. إصلاح صناديق التقاعد في بلد ما. To change in that. Because if we implement this reform now, the impact is not for next month and not next year. It's for many years. So we have to construct a long-term model. We have to construct a dynamic model. The same thing if we are looking what is the impact of in education sectors in relation with our demographic situation. We have to construct that and we have to look all the transition and we have to construct a dynamic model. But generally, it's a difficult one. The most common version of a CGE model are static, and this is a limitation. And if we want to construct a dynamic model, is too difficult to construct it in a theoretical level and in the numerical level. Okay, next limit is the CGE model is essentially neoclassical one. Okay, but we cannot deal with that in this situation. We cannot deal with a monetary or financial issues. If you are looking for a model where you want to use a monetary or to see the impact of a monetary policy or a financial issues, you cannot use a CGE model. Just to give you a mistake, it's a common mistake when you are using CGE model. Some people told us, I am looking for the inflation in a CGE model. It's wrong. We cannot analyze the impact of monetary policy or look for interest rate or look for inflation in a CGE model. We can do that in a DSGE model, in the dynamic stochastic general equilibrium, not in a CGE model. So the CGE model cannot deal with a monetary or a financial issues in an economy or a cyclical situation. Next limit. The choice of a closer. I told you before, when that model is not square, because we have more variables than equations, we can have altogether the same model. Each of us to select exogenous variable, we will finish by different model because we have some different exogenous variables. Some of the variables are obviously exogenous. Yes, international price for a small economy. I don't know, exchange rate for some economy, price for some goods administratively fixed by the government, etc. There is some variable are exogenous and it's clear. But for others, I don't know. Just to give you an example. Can we fix the government expenditure or can we fix the deficit for the government? We fix the ratio I don't know, of the saving or the ratio of the investment on the GDP. It's different. If we have to select the closer, we will have a different result in the simulations. The closer to close the model, we can change quantitatively and qualitatively the results from one closer to another. And this introduces some skepticism on that. If you have to look in a paper or to understand the result of a paper, go and see what was the closer. Unfortunately, some authors, they not to put in the paper what is the closer. We have the results, we have the table, perhaps we have the model, the structure of the model at the end in the annex of the paper, but we don't know what was the closer. We cannot understand the model. So I can continue for many hours to tell you about the limitations of this model, but there is some precaution to take when we are looking back. And there is obviously a possibility to overcome this, and the researchers are doing that. This is the part of theoretical aspects. Now, I give you all the limits on a practical level. I think you understand now the complexity of a CGE model. It's a highly demanding construction. This is not a limit for you. You are here to understand and to go ahead and to construct your model. It's a good thing. It's a good news. Now, be aware that you need, it's a heavy demanding construction. It requires a lot of time and a lot of data to construct that framework. Generally, this mobilizes a large multidisciplinary work team. Yes, we have to be economists. Perhaps we have to understand national accounting. You have to read exactly what is a sum, how to construct a sum. We have to be statistician in many situations when we have to use a data from a surveys. We have to be econometrician to understand, at least in part, to understand difference between parameters, variables, exogenous variables, endogenous variables, free parameter, calibrated parameter. We have to understand that to understand and to construct a model. It may require a simultaneous contribution of several departments, as I told you before. In some situations, the handicap in some administration is to have the computer and to have the software. In many situations, the administration had no access to the full licenses to GANs situation. I don't know what do you have in your administration, but I know in some administration there is no access to the GANs to solve this model. And this limit should not be broke the understanding and construction. We have to use that. Just I tell you the problem we have. But I encourage you, of course, to do the adventure and to understand what is CGE model with this the introduction training with my colleague Shahir and Dorothy. We are here to explain you at least in an introductory level what is the CGE model and why we have to construct it and why we have to understand the model. I will stop here I think I am in time. I have 5 minutes. If there is any question, we are here to answer your questions. Thank you.
Thank you so much, Tuhani, for the first part. We're going to break now for 15 minutes, and we start exactly in 15 minutes with the second part to introduce the macro and the micro tools needed to build CGE models. Thank you all, and have a nice coffee break.
Okay. In this part, what we have to do, we have maybe 2 parts, and we have to look in the microeconomic fundament of the CGE model. That's just a part, just an introduction. And in the end of this session, I will present you just a form of what is a sum. I select a small one to present it to you. So, so the microeconomic fundament, I don't know if you can see me. Shahir is good from there. Shahir, c'est bon?
We can see you, but we can't see the screen.
Yes, Dorothy will share.
No, sorry. We see. I mean, you're talking about you're sharing the screen, and we can see it. I thought that you're talking about the blackboard.
Okay, no problem. So you can imagine me, but you can see that screen. This is what is it. Okay, no, it's a microeconomic of the CGE. What we have to see is principally 2 aspects: the production function and utility function. It's the main part of in a CGE model. We have a trade also, but for this session today, because we have not in the urban economy, we will look for tomorrow the model, it's closed model, and we have to look what is the fundamental microeconomic aspects behind a model in a CGE model. It's in a production function, some generalities, and after that, we have to analyze more and small details in a Cobb-Douglas situation in a CGE model. What about the Leontief one and an extension to such CES model or CES function? We are for the utility function, we will see in a Cobb-Douglas, in a linear Drummond, in a Stone-Gurry, because it's an important one we can use in a CGE. We generally use it in a CGE model. Est-ce que tu as les graphiques? Maintenant, c'est arrivé? Okay. Just to see if we have, not yet. Okay, just to explain you what we have to do. Okay.
Do you see the screen now? It's okay?
Shahir, vous voyez l'écran?
Yes, we.
Okay. Now, when we are in a CGE model, generally, if we not by production level, the level of the production is I put U is a production. Generally, we have to combine between many things. The small one is consumption, intermediate consumption. I am writing in French, I'm sorry. But we have also the value added. And here we have to combine between 2 aggregates.
No, Tuhami, we still see the slides, not the board.
Yes. Just Dorothy will share with you.
Okay. Est-ce que je peux dire quelque chose?
Oui, oui.
En fait, on voit la présentation et on vous voit sur un autre onglet. Seulement, le problème, c'est qu'on ne voit pas le tableau.
Ouais,
L'angle de la caméra, il n'est pas bien positionné.
on va essayer de corriger ça si vous pouvez voir. Est-ce que vous voyez maintenant le tableau?
En cours.
En cours.
Toujours pas.
Voilà, là on le voit.
Vous voyez maintenant?
Oui.
Très bien. OK, donc ici, we have the production level, we have intermediate consumption, and we have the value added. Generally, when we are looking, suppose we are in the activity, G activity, so you can see it's industrial activities or order. We have to use many intermediate consumption. It's from some other sectors coming from 1, G, and G. This is the consumption, intermediate consumption used. And we have, in the sample situation, we have capital and labor. And we have here a combination. Okay. So the story when we are modeling in a CGE model, we have to look how to modelize to answer this question, how we combine this, and how we combine this. So we have, in this situation, we have 3 questions in 2 levels. This is the level 1, this is the level 2, but we have one on the intermediate consumption and the order in value added. In what we will do, because we have no time, generally we focus what we have to do now, we focus only on the part of value added combination. So the production, when we are modeling that, this is a volume. All what we have here is a volume. But to link volume with price, I told you that before, we have to look on prices. We have the price of the production here. We have the price of value on the consumption intermediate. We have the price on value added here. We have salaries here, right? And we have capital here, and we have arrangement, and we have the price of all other goods. And when we have a shock or we have a policy here, all those variables have to change. So there is a general equilibrium impact. Now, just to verify if we receive an illustration, I send an illustration to see if it is here. Okay, go. Tu la renvoies. Okay. Okay. Now we are looking at that. What we have to look on here, generally, in this level 1, generally, we have to specify something like that. Just to, we can put something like that, just to give you an example. For now, it can be a value added, generally is a value added in the activities on and intermediate consumption. This is a Leontief specification. Why is a Leontief? Because generally when we have to produce, there is no substitution, no possible substitution between intermediate consumption and value added. We have to use simultaneously the 2. And we have something like this. No, I have some illustration here. Do you can see the screen? Yes.
Yes.
We can see the slides. Yes.
Yes. Okay. This is what we are. I am using in another representation what I am about. So we have the production, we have the consumption, intermediate consumption, and the value added. This is a standard specification. In the first level, here we have a Leontief. There is no substitution between the 2. When we are speaking about Leontief in a CGE model, the story is there is no substitution. And after that, in the second position, in the right, when we are decomposing the value, intermediate consumption, we are in the input-output table. It's exactly what we have in the input-output table. In the left side, we have the value added is the combination between labor and capital. We have, just to give you example, we can disaggregate all this situation. We can look for, in this example, we have 3 labor qualification. If we are in a country and we want to modelize an impact of a policy in labor market, we can stratify the labor market on under-qualified qualification, low qualification, intermediate qualification, high qualification. And we will have 3 categories of labor, and we can have the same thing in capital. This is a nested function because we have many levels many levels of what the structure of production. Another example maybe is coming from a real one. If we have any in different region or different type of you are using many factor of production like water or I don't know land, natural resource, etc. We can disaggregate. This is an example from a real example. If you want, I think Shahir, it's from Mirage. This is the structure of production of the model Mirage from the France. This is another example to give you the situation like this question we had in the end of the session, the precedent session, where we have to modelize, where we have many fossil fuel, heat, electricity, heat, order electricity. This is a structure coming from a model in, I think, a Chinese model. This is the structure that they are using. This is only to give you an example when we are using how to modelize a production in a CGE model. Now we come back to how we can do the mathematics of some part of that. Okay, I go directly for, this is the first one. Now with this structure we had here, you know, in the equilibrium we will have necessarily, because I put G equal C, G. We must have this. If you to know, I think you know that in a Leontief situation, we have no substitution and we have something like this. So here we have CE and here value added, and we have that the optimum is here. So the equality must be something like that. This is for the first level. If you see, this is a Leontief. This is a Leontief specification. There is no substitution. So no substitution. And if you see the price, there is no price in the situation. In the Leontief situation where we have only complementarity, there is no, the price no role in this situation. Now I go to the value added in the left hand side, and with I will drop that. If we have to use a function between K and L in this situation here, this is a Leontief, but here we have to use. Generally in a CGE model, we have to choose the type of the F function, but we have no many situation. The first one used in a CGE model is the Cook-Douglas function. This is our purpose here. So I write it Y, and I am using a Cook-Douglas function. What it means? It means that if you have any question, you can stop me. Huh? We have something like that. This is really it's a value added. We are using value added, but I put Y to be consistent with the model we have to use in the other part in this form. So the combination of that, I think you know all this. So we can use it, and it can be different by activities. It's important in a CGE model. Each activity has his prediction function because there is a difference of intensity of capital and labor in each activities. It's different. I put it like this, but it can be different. It must be different between activities. But now what we have to determine, we have to know what is the value of K we have to use and the value of L, the factor demand. We have to deduce a factor demand. Generally, in a CGE model, we have this production function, and we have to deduce that demand. How to deduce that demand? This is the fundamental microeconomic behind this model. We have generated to maximize profits in each activities. If you have to, we have the price of the output of the value added in this situation minus salaries minus capital remuneration. Okay, capital remuneration. So this is the profit. And we have to deduce that demand is only to derive for each component we are looking for the labor, and we have to derive for the capital. Okay, but we know that the Y, we have the specification here. So in this situation, we have to derive what we have to. We have this one, this is the first one. We have alpha, beta, sorry. Because it's A, so this is beta, A, alpha, L, beta minus 1, W equals 0. And the second one is alpha, A, alpha minus L beta moins equals 0. This is what we have. We can rewrite it like this, just to be simple to manipulate. It's beta. Here is the same thing, Y on L equals W. Okay. And we have somewhere here P. Because we are deriving only Y here, and we have P. So here, okay, in this one is alpha, Y on R. This is the relation we have, the first order condition we can deduce from this. Okay, and we have here a very interesting situation we can deduce from equation by equation here, what is called factor demand. Well, okay, good. No, okay. Now, we have many information from there. If I take this one, equation 1, and this one is equation 2, we can do this many things. Equation 1 gives me the relation, the factor demand, if I am looking for equal L equal, I signed this one from this, equal Y, this is the demand for the labor factor. This equation must be in the model, this one. The same thing I can deduce exactly by the same structure, alpha. This is the demand for capital factor. And the two equations must be in our model because we determine this. Look, the characterization of each one, when the price of the output increase, the demand of the labor increase. The same thing for the capital. When the production increase, I need more labor and more capital. When the price of one of the other factor increase, we decrease the demand of labor or decrease the demand of capital. This is what we can, this is the demand factors if you want. This is the demand of each one of these factors. We can also give an interpretation of the two parameters we have here. The first one, if we have to deduce the interpretation of beta or alpha, just to remark here, generally we impose that there is a constant rendement d'échelle constant, constant return, like this. So in this situation, we can deduce that without this condition, but we can deduce that if there is. Now, we can deduce that part of the labor, beta equal, the interpretation is clear. We have beta is, in this interpretation, when we are using prices, is the part of salaries in our activities, because this is the price of the output, and this is the price or the salaries in this. This is the same thing for the order one, for the capital. We can deduce the same thing. This is the interpretation for the two parameters. And for the Cobb-Douglas, the two value, the value of the salaries and the value of the production, we can deduce that from the sum. This is why in many CGE models, the researcher and the practitioner use the CD, because the CD function. Why? Because it's easy to calibrate the two parameters we are using, particularly when we have a constant return to scale. Another interpretation, because we are here, another interpretation of that is if we rewrite the production function, like I think, yes, L beta, you see that when we are writing that, it's clear alpha and beta, it's the part of each factors, but also it's the elasticities. It's clear from that. If we take the logarithm of the two part of the two sides of this equation is ln plus beta ln L, like this, we see directly that alpha and beta are elasticities from the two, because it's the derivatives of ln and the derivative of ln equal alpha, and the derivatives of ln y of the logarithm of the two factors are like this. So it's clearly the sorry, this is L. It's L here. So you see that alpha and beta, we have also another interpretation of the two is the elasticities. So this framework is generally used in a CGE model because it's easy to use. So the second level is that in some situation, we can see a very interesting characteristic also from this. I use that. Look at for the two relations here, the relation between the two equations I used before. We can deduce the two ratio. And here it's because we can simplify by the two numerators here, this one and this one collapse, then can we have something like that? And what we see here is very interesting, and a very interesting characteristic here. Look, from there, we can deduce the variation of the two parts of this equation, just to give an interpretation, is a constant here, is a ln beta sur alpha is a constant, but for the two variables, what we can deduce from this, the derivatives of the logarithm of the ratio between the two factors and the derivative of the two price of factors, the ratio of two factors equals 1. And this is the definition, exactly the definition of the substitutability, the elasticity of substitution between K and L what we generally noted, sigma equal 1. The Cobb-Douglas specification for the production is characterized by the elasticity of substitution equal 1 in ACD. What it means? This is a mathematical result, yes. What it means in economics? If you are using a Cobb-Douglas specification in the model, you are assuming this. You are assuming that when the ratio of price, or factor price, in this situation, labor and capital, or decrease or increase, the rapport, the ratio of labor and capital increase by the same percentage, because we are in a derivative of logarithms. And this is a limitation of the Cobb-Douglas. We have the powerful of the Cobb-Douglas is that we are using a Cobb-Douglas specification. It's easy, but the limitation is that we are supposing when we vary, when the ratio of the two factor vary, the level of the volume vary in the same percentage, because the elasticity of substitution in ACD equals 1. With this limitation, the researcher and use another specification, and the other specification is precisely the CES. I think you know that CES specification is an alternative use of the specification here. And this formulation, I think I have no time to develop it. I don't know if we have in the package the notation. Dans le document de Shahir. I will just to give you the, just 1 minute, please. Okay. Do you see the screen? Okay, go.
Yes.
Okay, thanks. Go. Okay, thanks. Donc, here you have a specification. Sorry, I'm looking how can Okay. You have here the specification of a CLS prediction function. In this specification, you see that we have capital and labor, here noted N in this slide, and production is Y, and we have many other parameters. But this is a constant elasticity of substitution. If you use this, and we change some notation, what we deduce in this situation, we found something like that. Just to give you an example, K on L, there on L, R or W on R equals sigma. And generally, it can be different from 1. What it means? This means that when we are using a constant elasticity of substitution, the variation of the volume of the report of the two volumes, the capital and labor, when the price, the ratio of price vary. There is a variation. We have the variation between the two with a constant value. And this constant is different from 1. It's like we have something like this, just to be more clear. If we solve this problem, because we have no time, we have constant here plus ln W on R. What it means, we have a relation like this, and this is the constant elasticity. In the Cobb-Douglas function, production function, this is equal 1. this is equal 1 in ACD. This means two things. When price change, how the report in the two factor we are using here change. In the Cook-Douglas, the parameter, the elasticity of substitution is equal 1. But in a COS production function, we have more possibilities, and the elasticity of substitution is different. One is equal to another value, and in a CG model, we can use a COS specification. The problem is, in this situation, generally we don't know what is the value of sigma. And in that calibration, if you look, I think, je crois qu'il y a une spécification plus bas. Yes, in the perfect calibration here. No, just to show you some, yeah, here. If you see here what we have, just to understand the philosophy between the two. When we have the isocont is something like that, here you have a Leontief, because there is no substitution, it's a strict complementarity. Here we have a strict substitution, and between the two, we have many possibilities, a continuum of value of the elasticity of substitution. The particular one is when we are with sigma equal 1, in this situation, gamma equal 0, and we have the Cook-Douglas specification. This is to summarize. When we are modeling the value added in a CGE model, we have to characterize the substitutability between the factors. If there is no substitution, if in our activities there is no substitution, we use a Leontief. This is a strict complementarity between the two factors. If there is a substitution, we have to use CD or Cook-Douglas or a constant elasticity of substitution. If the elasticity of substitution equals 1, we are using a CD. If it's different from 1, it's different, we have to use a constant elasticity of substitution. The constant elasticity of substitution is a generalization of the two other situations. But it's a generalization, it's an interesting feature, but if we are using a COS, we need three parameters when we have to calibrate the model. And this is econometric issues here, because we need data to estimate these elasticities, and generally we have not it. And we have to use an arbitrary parameter from outside the model, and this is the limitation. This is the reason why in many models we have two possibilities. We are using a Cook-Douglas prediction function. Yes, we are fixing the elasticity of substitution equal 1, or we are using arbitrarily value for the elasticity of substitution in different branch. Okay. Questions, yes. This question here, just to interact with you. If you have any question on prediction, I prefer to answer your question than to go ahead. Do you have any question? At least now, because we have no time to go more. If you have questions. Any question in how to modelize prediction? Pas de question? هل من سؤال? OK. Pas de question? OK. On va. Ça va? On va regarder maintenant. We are to look on the in the utility function and to look why and what we are doing. When we want to modelize the utility function, it's very interesting in the CGE model, particularly when we are looking at the impact of a policy on a household, in a household side. What we have generally, when we have a household, we have the income, and the income is used to pay a tax, okay, to consume, to cover the expenditure, and we have a saving if there is. And when we are looking for the total consumption for a household, I note that total consumption for the household, it can be the same thing if there is no saving, it's the income. I think in the GANS code we are using income. If you have income, now we have to use some consumption. Suppose we have to use perhaps N goods. Because we have a disaggregated situation, we can use N product because the household have to choose between N products. And we have to maximize this utility generally under our contract. Just to put it clear, suppose it will be price of goods equal a total consumption like this. This is what you know in a macroeconomic analysis. It's clear, it's very easy. Now, this is the theoretical problem. In a CGE model, yes, we must have something similar to the contract like this, but we have to know what is the utility function we can use. Like in the production side, we asked exactly the same question, and we are using a Leontief or a CD or a constant elasticity of substitution. In this situation where we model the household side, that one side, we have to precise the utility function. In the CGE model, generally, we have many, but we have two particular situations. I think you know some of this. We have to specify the Cobb-Douglas utility function, or generally also we specify a linear expenditure system. There is other demand, system demand, but for the introduction for some of you, we take it easy and simple to understand the philosophy. What it means, we are taking a Cobb-Douglas utility function. It means that the function we have here is something like this, because we have in product something like this. We have to maximize this. To be clear, suppose just to keep you with me, suppose that to take it easy also, suppose we have only two products, C1 and C2, and we are using a utility function, Cobb-Douglas utility function. This is alpha 1, C2 alpha 2, and we suppose alpha 1 plus alpha 2 equal 1. And we have to maximize this utility function for C1 and C2 under the budget constraint of the constructor. It's CT or Y equal P1, C1, P2, C2. It's a very simple mathematical exercise. What we have to do, because I don't know if you have time, but we'll try, we construct the Lagrangian of this function. By definition, what is the Lagrangian here? Is C1 alpha 1, C2 alpha 2, plus we have something like this, huh? To derive. You take the first order condition of this optimization program, and for some step I let you deduce the steps. I think if you have a question, stop me, but I think it's a very simple exercise just to go behind. What we deduce something like this. C1 equal alpha 1 equal P1 and C2 equal alpha 2 on P2, something like that. If you verify, you will obtain something like that. It's a very interesting result. It's a sample, and we have interpretation like in the prediction side. We have interpretation of alpha 1 and alpha 2. From this one, we deduce clearly alpha 1 equal P1 C1 on U. And from the second one, we can deduce alpha 2 equal P2 C2 in Y. Okay, what it means, alpha 1 and alpha 2, we have coefficient budgetary coefficient budgetaire. So the Cook-Douglas specification on the utility side in a CGE model, generally, we are using a Cook-Douglas utility function. Why? Because it's simple. And we can calibrate the two parameters, alpha 1 and alpha 2, and we can generalize. If you are using in goods, we have to deduce only CE. If we have many products, it's alpha E, Y on PE. It's exactly the same thing in a generalized situation for the household. And it's very fast, it's simple to use a Cook-Douglas utility function in a CGE model because we can calibrate the parameter directly from the sun. Why? Because we can observe what the household use for each goods, for goods 1 and for goods 2. We know. Or in a generalization, we can look what is used for each goods. For each good, we can know that. And we can deduce the coefficient budgetaire, the budget share, directly from the sum. So we don't need econometrics approach or complicated approach. But, and this is the real problem. So, please, for some who is not with me, please, if you can follow this part, look of this. This is generally what we have. If we have the situation, this is the generalization. I used it before. Look, what is this? This is the demand. The production, the consumption is a increasing function with the revenue, the income, or the expenditure, general expenditure. Why? Because as you see, this is, and it's a decreasing function with P. To be more clear, look at this one. I think you know these results. If you take the logarithm of the two sides, it's a logarithm of E plus the logarithm of Y, moins the logarithm of P. What it means? This means if we are using the Cook-Douglas specification, the income elasticity of the demand, the income or the depends on the expenditure elasticity of the demand equals 1 for each good. For each good, the elasticity is unit. What it means? If the income increased by 10%, the demand of each good increased by 10%. If the revenue of the income decreased with 10%, the demand of the consumption of each good decreased in the same proportion. It's a limitation. And we have also the elasticity, the direct price elasticity of the demand for the price, the direct elasticity, equals 1. What it means? It means that when the price, if I simulate any policy, that when the price of the good rise by, I think, I don't know, 10%, the demand of the good decreases by 10%. And the last critic and the last limit of the Scope-Douglas specification is this. Look at in a mathematical writing, and I will interpret it in, if the price go up to infinity, this limit is 0. In the mathematical specification, this is the story. But in the economic, if we want to give an economic interpretation of this, when the price rises, the consumption can go to 0 for all goods. This is a real limitation of this specification. Why? Because if we are consuming bread or milk or eggs, if the price increase, the demand decrease and go to 0, this is unrealistic situation. For this limit, the researcher proposed to use an alternative specification in a CGE model. This is the one generally used, but we have another specification. Another specification, it's what we know on the Stone-Gurry specification. Stone-Gurry specification. What it means, Stone-Gurry specification, is exactly to go behind this problem and to specify that we can have a minimum to consume in each goods. This is the situation here. Okay, we have that specification from the slides here, because I have not to write it twice. What we have here, look, please. If we write this, this is the demand for the goods. This is the demand. This is the price. Huh? We can simplify this writing and deduce C E equal A C min, the minimum, plus I'm using the sign just to change the notation, the Y, just to give you an interpretation of this. There is a difference. Look on what we have here. If we are using a Stone-Gurry utility function, the expression of this is like this. It's coming from, if I write it in something like that, CE, 1 CE min on gamma E, something like that. This is the specification of the utility function here in the corner. And we deduce the demand function here. What we have, the C min is the volume of the good E we have to use necessarily. Suppose it's bread, sugar, oil, I don't know what. This is the minimum commodity we have to use necessarily. And after that, we are using, look, this one is independent on price. And this is the minimum we have. And here, it is what we call the surnuméraire. Surnuméraire. When we pay for all the minimum we have for each goods, and we look for all the expenditure or all the income, and the difference can be used between other goods. This is the specification. It's a very interesting one because even the price increase, we have to consume the minimum. If you want this component here, is like a poverty threshold, poverty line, because we have absolutely need to consume for each good what we have here. It's a very interesting behavior, but with this specification, we add at least n parameters, because the minima here are not known for households. It's difficult to estimate the minima. We cannot do it using only the sum, the accounting framework we have. We cannot estimate it. We have to calibrate that. And to calibrate that is not easy. We have to take an econometric approach on what we call fresh parameter and to calibrate this. For this difficulty, for this problem, the modeler avoid to use a LOS specification and refract to use a Cobb-Douglas specification. You see that the dilemma we have when we are doing modelization. We want to go ahead and use a more rich specification, but we have a limitation because the econometrics and the parameter we have to use are difficult to estimate. This is why generally the researcher in the paper you have to read and to see, generally the authors use a Cobb-Douglas in the production side or a Cobb-Douglas in the utility side. Only because we need a parameter because we cannot calibrate them in that situation, the small situation or the some situation. So just because we have no time, but just to clarify something, when we have a CG model, in the CG model, when we are modeling the production side, we have to use a specification. For an introduction level, we can tell that we have to use one or the other specification, Cobb-Douglas or COS. We now know the COS is a generalization of the Cobb-Douglas one, but they are using the COS use the elasticity of substitution that we have not, particularly when we are in the disaggregated situation, because we need a elasticity of substitution for each activity we have in the model and we have in the sum. In the utility side, the authors that use, the researcher use utility function, the Cobb-Douglas utility function, because it is easy to calibrate, but we have many limitations that those I have Sulain before I have give you the problem we have when we are using the Cobb-Douglas utility function. We can use a Stongury specification. There is other demand system we can use, but in advanced level, if we have another training, I can tell you more on that. We have what we call AIDS system, almost ideal demand system. We can use a CDE demand system, constant difference elasticity system, and others, but is in advanced level, and we have no time to go there. Just for this introduction, if you need, we can give you more insight on that. We have also quiz. If you go in the internet, we can find quiz system, but it's more difficult and it's there's many difficulties to handle in econometric level. I will stop there for the two specification. I'm looking on my clock to go to a sum. But if you have a question on this part, I'm here. If you have any question, for production side or consumption side, or a general question on that. Yes. Is there any question? Est-ce que vous avez des questions sur la partie consommateur, la partie producteur? No question? Good. There's no question because it's not clear or it's clear. I don't know. Shahir, are you here?
Yes.
Is there any question? More clarifications?
Well, on my side, everything is clear. I don't know if anyone has any further questions. I think that this part is really important because, as you will see tomorrow with Dorothée and myself, when we will start building the model, we will basically rely on all those functional forms ranging from, for the time being, Cobb-Douglas mainly in the simple versions of the model, but at a later stage on constant elasticity of substitution and similar functional forms. So the better you understand those functional forms, the more or the easier you will be able to derive all the equations manually. And actually deriving the equations manually is, I think, is really fundamental when you start working on CGE models. And that's why you will see today, like what Tuhemi did, and tomorrow Dorothée and myself will do, understanding the mathematical idea behind the equations is really important. So that's why we're spending a lot of time on that to make sure that we understand all the technical details relating to the model building itself.
Okay, if there is no question, I have some consideration. We can look at the what is a sum. We can speak on macroeconomic consideration in a CGE model, and particularly on the sum. I choose I have to choose a small matrix. As with Dorothée, we chose a matrix from the book of Ducaluy, Martens, and Savard. It's a matrix. I have the opportunity to participate in this book with two chapters. One of these chapters is the sum in this book. Is a sum from Morocco, but it is not. This is the point. Just to give you what it means a sum, what it means a matrice de comptabilité sociale. What is a sum? Just to give you a definition, you have just to listen, please. A sum is a counting table. It's a matrix, it's a table. Donc, c'est un tableau. It's a counting table. What we have in this table? We have the flow for a year or a period. It's not a stock, it's a flow for a period. And it's covered all flow in the economy. For this example, if you see, so the table is, we have the same number of row and the same number of column. Each account we have in a row, we have it also in the column, exactly the same. But obviously, the interpretation is different. Yes?
No, I have a problem. I'm sorry.
Can you see the?
No, it's there is a problem. I will reload.
Sorry, we have to reload because you cannot see the matrix item.
C'est bloqué ça.
Okay. Je peux le faire.
I'm sorry.
Control X. We have a problem with the screen. You cannot see the screen.
Microsoft.
Huh?
Microsoft.
I'm sorry.
No problem, Tuhaim. I think it's relatively clear, so we can pursue.
Okay, just I continue. Dorothy will try to give you that. We cannot change the page here, but the story is so the sum is a table, is a counting table, and what we have in this table, all account we have in row, we have it in column. In the row, we have the income or the resource for each count. And in the column, we have the spending of each count. So we have the equality between the two. The total of a row in a sum is strictly equal to the column. What account we have generally? We have the production factors. We have the agents we have in the economy, household, in different category of household, firms, government, and the rest of the world. If we have to modelize the part of the world, the rest of the world, and we have the production activities, productions, and in this production we have the product, and in product we have the product who can sold in the market, in the domestic market, and we have the product for exportation. This is the relation with the rest of the world. Inside the matrix, we have on all cells, we have the flow between all what I said before, between the production factor, agent, production, activities, product, and orders. We try to give you the illustration, but I'm sorry, I don't know why, because we have a problem with the screen. But in the sun, we have the production.
Dorothy, would you like to stop sharing and I will try to share?
Yes, please.
Can you see it?
Not yet. No, Shaya.
And now?
Yes, go to the last slides. After Excel. This is.
This one or the previous one?
Yes.
Yes, this one.
Okay.
But
The
first one, the page before, this one page before, this one. Thank you. I but I cannot write on that because it's the share screen, but no problem. Look at the column 9. They have the activities. And in the activities, we have agriculture, this one, and we take it here in the column. In this one, we have when we cross the labor, we have the salaries. And when we cross capital, we have the capital earning. Yes, this is salary. This is a capital earning. Okay. And here, when we cross the government, we have the tax on the production. This is. After that, we have this is the intermediate consumption used in these activities. Okay. Ça, c'est la consommation intermédiaire on the activities. In the total is the value of the production in a factor level. This is the value of the production. It's exactly the same thing when we are looking the second column. So now we are looking in the first row and on capital and the first row in labor. We have the salaries for each activities. And if we go to the second page here, the next page, and we are looking for the total, we are looking the total here. You have the total of the salaries in the economy, and we have the or the total of capital return in the economy. And we can add the two components. We deduce the gross domestic product in the return level. In the production level, we have the value added here, and here we have the total of the gross domestic product. You see that in a sum, we can give the interpretation of all the flows in the economy. So, Shahir, I'm sorry, we go to the page before. If we are looking for the households, the households agent here, you can take one of the three households here: household, poor household, intermediate household, and rich household. We can look in each row. We can look for the incomes of these households. For example, for poor household, we have the part of the salaries they are earning. This is the salaries, and we have transfers. In the middle here, we have the transfers between agents. There is a matrix of transfer. This is a transfer from household to household, intermediate household to poor household, etc. Now, if we are looking the column of household, one column of household, we have to look what they give to other households, and this is importantly, we have the consumption in the middle, the consumption of household. This is the consumption of the goods we have. Just to summarize, because we have no time, when we are looking in a sum, all cells have an interpretation. And in a sum, the sum cannot be used to make calculation by itself. We have interpretation of all things. In a sum, we have some cells that is 0, and there is a cells where there is no value in the, c'est-à-dire des cellules vides, empty cells, because there is no economic signification. But the sum is a table where we have flow between agent and the economy, all agent or activities in the economy. For a space, it can be a country, it can be a sub-country, it can be integration. We can construct a sum for CDAO or for CCG countries or others, and we can construct a matrix for a part only of a country. It's with all the flow is in the same money. If we are constructing a sum for Egypt, it must be in the money, national money of Egypt, or in dirhams in Morocco, and it must be within for a year or for a period, because we are in a flow. This is the data we have to input after that in a numerical framework in GAMS in this situation to feed the model to calibrate all the parameters we have. Just to give you an example, if you use the salaries we have here on the value added, we have what we call alpha in the production side. And we are, if you want to use the parameter in the utility function, we have to use the consumption of each product in the column 3, 4, or 5 on all the consumption, and we can calibrate a Cobb-Douglas parameter if we are using a Cobb-Douglas utility function. This is what we can tell you in some minutes on a sum. Prepare your question on the two parts, on production, on consumption, and on social accounting matrix. We will take some minutes tomorrow to answer your question, to prepare this. If you have any question, you can prepare this question and we can answer that for you tomorrow. I don't know if my colleague Dorothy has something to add, or Shahir, if you have any question or something to add.
Thank you, Remy. Any questions? Anything to add?
Questions?
Gracia?
Yes, so I just have one small question regarding SAM. For example, and like the example you showed, it's it's going back to 1990. And
Yes,
for example, if we are in 2025 and we are examining like the impact of a specific policy,
yes.
so is it accurate to use a SAM that dates way back,
No. Yeah, it's a good question now. No, we are constructing a sum for a problematic. We have to use a relevant sum and updated sum. In this example, because we're constructing it for a pedagogical purpose, and we are constructing it for in the 2000 for a book. So yes, it's old one. It's not relevant to construct a matrix for all the situation. This is only for pedagogical utilization. We have a new matrix where we are looking for, I give you just an example where I worked before. For a Moroccan situation, we have a new sum for the earlier years. And no, it's a good question. When you have to construct a matrix, we have some limitation. We need an input-output table, and we need a new survey on households and industrial surveys. And it must be the updated data we can use. This is the answer for this question. Rasia.
Thank you.
You're welcome.
Any other questions? Okay, so if we don't have more questions, thank you so much to Hami for the very pedagogical presentation today. This will be very useful for what we'll be doing tomorrow with Dorothée. Dorothée, would you like to add something?
No, I think that as you explained before, tomorrow it will be more clear why we go back to the micro theory and macro theory. And I think tomorrow we illustrate, and also we will go to GAMS, then we will see also how to implement all these theoretical parts in the practical model and in GAMS. And we also, tomorrow we present a small presentation, initiation to GAMS, and presentation of the software.
Yes. Great. So just a couple of logistical notes before we leave. So tomorrow we start at the same time. Make sure that you install GAMS before joining, because you will be able to practice at the same time if you want. Third, at the end of the training, so next week, you will receive a link from Ramaj with all the material in terms of codes, slides, and relevant references if you want to dig deeper into the CGE literature. And with that, we can conclude today's session. Thank you all so much. And we meet tomorrow at 4 p.m. Cairo time. And have a nice evening. Thank you all.